Hello everyone, welcome to the lecture again. In the previous lectures, you saw that integrating the equation of motion, that is F equal to ma with respect to displacement, gives you the work energy equation. Today we are going to see that integrating the equation of motion, that is F equal to ma with respect to time, will give you the impulse momentum relation. So let us see that. Let us start with the Newton's law. Summation F equal to dP by dt. Now integrate this with respect to dt. So integral F dt will be integral dP. So I just multiply dt on both sides and then integrated. Let us say t varies from t1 to t2 and momentum from 1 to 2. The quantity which is on the left hand side is called the linear impulse of the force. So this is linear impulse of the force. So we have integral t1 to t2 summation f dt equal to p2 minus p1, or let me write it down in the natural sequence. So we have p1 plus integral t1 to t2 summation f dt equal to p2. So this is the impulse momentum relation. This tells us that if a particle is moving with a momentum p1, impulse f dt is applied on it, then its momentum becomes p2. So let me write it down in the text. The initial linear momentum of the body which is p1 plus the linear impulse applied to it will be equals to the final linear momentum. Now this equation we can write down in Cartesian coordinate, component by component. So let me just write down this component form in Cartesian coordinate. Okay. So for x component we have p equal to mv, so m v1 x plus t1 to t2 summation the x component of the force, so summation fx dt equal to p2, p2 is m v2, but you have to take the x component of the velocity also. So for the y component we have m v1 y plus t1 to t2 summation fy dt equal to m v2 y, and similarly for the z component we have m v1 z plus integral t1 to t2 summation fz dt equal to m v2 z. Now with this very basic introduction, let us look at some of the examples based on this concept. So question number 1, the problem statement is a particle with a mass of 0.5 kg has a velocity of 10 meter per second in the x direction at time t equal to 0. Forces F1 and F2 act on the particle and their magnitude change with time according to the graph shown. Determine the velocity v2 of the particle at the end of the 3-second interval, and it is given that the motion occurs in the horizontal xy plane. So, here note that the x axis and the y axis are given. Two forces F1 and F2 are acting on it. F1 is acting in minus x direction and F2 is acting in plus y direction, and their magnitudes are given here. So, we can use the impulse momentum equation to find out what is V2. So, we have P1 plus T1 to T2 summation F dt equal to P2. This equation I can write down in the x direction. So, in the x direction we have momentum P1 which is equal to m times v, mass is given. So, 0.5 into its velocity v, it is given that it has a velocity of 10 meter per second in the x direction. So, multiplied by 10 and then plus integral T1 to T2 f dt. Now, f is acting in minus x direction. So, therefore, minus the force from 0 to 1 second, it is 4 Newton. So, 4 into 1 f dt plus then from 1 to 3 second, that is for 2 second, the force is 2. So, this is the value of f dt equal to P2. P2 is m times V2. So, from here I can find out what is V2x. It comes out to be minus 6 meter per second. Now, let us apply the impulse momentum equation along the y direction. So, in the y direction only force F2 is acting, and it is given that the mass was initially moving in the x direction only. Therefore, there is no momentum in the y direction. So, in y direction we have P1 equal to 0 plus integral f dt. So, that will be the area inside this force. So, it will be 1 into 3 plus 1 half into 1 into 2. So, this is integral f dt, and it will be positive because the force is acting in the plus y direction, equal to m V2, m is 0.5 and V2 is V2y. So, from here you can see that V2y comes out to be 8 meter per second. Therefore, the final velocity v will be minus 6I plus 8j. Now, let us look at another problem statement. A 120 gram baseball is pitched with a velocity of 24 meter per second towards a batter. After the ball is hit, by the bat B, it has a velocity of 36 meter per second in the direction shown. If the bat and the ball are in contact for 0.015 second, determine the average impulsive force exerted on the ball during the impact. In this question, we have been asked to find out the average impulsive force. For that, we can use the impulse momentum equation. So, we have P1 plus T1 to T2 summation F dt equal to P2. Now, the situation is following: we have this bat and a ball is travelling in the horizontal direction with a velocity of 24 meter per second, and it is hit by the bat, and then the ball goes at 36 meter per second at an angle of 40 degree. So, we can write down this equation in the x and in the y direction. Let us look at this equation in the x direction first. So, in the x direction, the initial momentum P1 is m times v, mass is 0.12 because it is 120 gram, multiplied by the velocity, and it will be minus because the ball is travelling in minus x direction, plus summation f dt. So, force is Fx and dt is given. It is in contact for 0.015 second. So, 0.015 equal to P2. P2 is mass times velocity. Now, the velocity in the x direction will be 36 cos 40 degree. So, from here I can find out what is Fx. It is 412.6 Newton. Now, let us use it in y direction. So, initially, since the ball is moving in the horizontal direction, therefore, there is no moment in the y direction. So, it is 0 plus Fy into 0.015 equal to 0.12 into 36 sin 40 degree. This gives you Fy equal to 185.1 Newton. Therefore, force F will be 412.6 I plus 185.1 J Newton. Here note that when we calculate integral f dt, I have taken f as constant because that is independent of t, and we are looking at the average impulsive force. So, here we have assumed that both Fx and Fy is constant during the contact. So, when the ball is in contact with the bat, and it is given here because we have been asked to find out what is the average impulsive force. Now, let us look at another problem statement. A baseball player catching a ball can soften the impact by pulling his hand back. assuming that a 125-gram ball reaches his gloves at 160 kilometer per hour, and that the player pulls his hand back during the impact at an average speed of 10 meter per second over a distance of 150 mm. Bringing the ball to a stop. Determine the average impulsive force exerted on the player's hand. So, again to find out the impulsive force, we can use the impulse momentum relation. So, P1 plus integral T1 to T2 summation f dt equal to P2. Here P1 is given, it is mass into velocity. So, mass is 125 gram, so 0.125 into the velocity 160 kilometer per second. So, we can convert it into meter per second. So, it is 160 into 1000 divided by 3600, and the direction of P1. So, let us say this is the y axis, this one is the x axis, the ball is moving in minus x direction, therefore, it will be negative. So, that is minus 5.555. Now, the time t will be the distance which is given here 150 mm divided by the velocity which is 10 meter per second. So, therefore, t will be 0.150 divided by 10, and that comes out to be 0.015 second. Now, the final momentum P2 is given, it is 0 because the ball comes to the rest. Let us put it in equation number 1. So, we have P1 minus 5.555 plus f dt. So, f dt is 0.015 equal to P2 which is 0, and from here I can find out what is f. So, that comes out to be 370.37 Newton. Now, let us look at another problem on the same concept. A tennis player strikes the tennis ball with her racket when the ball is at the uppermost point. Of its trajectory as shown. the horizontal velocity of the ball just before the impact with the racket is V1 equal to 15 meter per second, and just after the impact its velocity is V2 equal to 21 meter per second directed at the 15-degree angle as shown. If the 60-gram ball is in contact with the racket for 0.02 second, then determine the magnitude of the average force R exerted by the racket on the ball. Also determine the angle beta made by R with the horizontal. Okay. So, again we have to use the impulse momentum relation, and for that let us say this is our plus x axis and this one is the plus y axis. So, we can use P1 plus T1 to T2 integral f dt equal to P2. We can use this equation in the x direction. It is given that the mass of the ball is 60 gram. So, therefore, 0.06 with minus sign because the velocity is in minus x direction. So, the velocity is 15 meter per second plus r x into dt, dt is 0.02 second. So, 0.02 equal to the final momentum after the impact along the x direction. So, that is 0.06 into 21 cos 15 degree, and from here I can find out what is R x, it is 105.9 Newton. Now, let us use this equation in the y direction. So, in the y direction initially there is no moment, so that is 0 plus r y into 0.02 equal to 0.06 into 21 sin 15 degree, and from here you can find out what is r y. It comes out to be 16.31 Newton. Now, let us consider that the gravity also act in the y direction for that small time. In that case, in the y direction we can write down the equation as 0 because there is no initial momentum plus r y into 0.02 minus the gravity. So, we have m into g into t equal to 0.06 into 21 sine 15 degree. In that case, you see that Ry comes out to be 16.89 Newton. So, you can see that if we do not consider gravity, even in that case the difference is very small, because the impulsive forces are acting for very small duration. Now, let us calculate R. So, R will be square root R x square plus R y square. Let me take this as R x and this as R y. So, it comes out to be 107.2 Newton, and in the question we have been asked to determine the angle beta that R makes with the horizontal. So, beta will be tan inverse R y over R x. Now, R y and R x is known. So, it comes out to be 9.07 degree. Now, let us look at one more problem. The small marble is projected with a velocity of 3 meter per second in a direction 15 degree from the horizontal y direction on the smooth inclined plane. Calculate the magnitude v of its velocity after 2 seconds. To find out the velocity of the marble, we can use the impulse momentum equation, which is P1 plus T1 to T2 integral f dt equal to P2. Let us look at the free body diagram of this. So, we have this inclination and we have this marble. Its weight is going to act downwards. There is no force along the y direction. So, f y is equal to 0 and the component of the mg will act along the x direction. So, since this angle is 10 degree, therefore, f x will be mg sin 10 degree and the ball is launched at an angle of 15 degree. Now, let us use this equation both in the x and y direction. So, in the x direction we have m v1x plus fxt equal to m v2x. Now, v1x is minus 3 sin 15 degree because the component of this v along the x direction is minus v sin 15 degree and v is given, it is 3 meter per second. Therefore, v1x is minus 3 sin 15 degree. fx is mg sin 10 degree. So, let us put this in equation number 1. So, we have m into 3 into sin 15 degree with minus sign plus mg sin 10 degree into 2 second equal to m v2 x. So, m will get cancelled and we have v2 x equal to 2.63 meter per second. Now, let us use this equation in the y direction. So, in the y direction we have m v1 y plus fy t equal to m v2 y. Now, v1 y is equal to 3 cos 15 degree, because the component of 3 along the y direction is 3 cos 15. Fy is equal to 0, and let us put this in equation number 2. So, we have m into 3 cos 15 degree plus 0 equal to m v2 y. M will get cancelled and from here v2 y is equal to 2.9 meter per second. Therefore, total velocity of the ball of the marble will be square root vx square plus vy square, which comes out to be 3.91 meter per second. With this, let me stop here. See you in the next class. Thank you.